हेलो दोस्तों, ये और एक वीडियो है लैप्लास ट्रांसफॉर्मेशन के ऊपर। और इस वीडियो में मैं आप लोगों के साथ स्टेप फंक्शन, यूनिट स्टेप फंक्शन क्या है और सेकंड शिफ्ट थ्योरम, वो दो टॉपिक डिस्कस करने वाला हूँ। ठीक है। नाउ व्हाट इज यूनिट स्टेप फंक्शन? यूनिट स्टेप फंक्शन nothing but for any real number eta belongs to R, the function g eta of t defined by g eta of t is equal to 1 if t is greater than your eta and 0 if t is less than eta, then this function is known as unit step function. Now if I try to find the Laplace transformation of this unit function, then what will be the Laplace transformation? Okay, let us find the Laplace transformation of this unit function. So let's begin. L of g eta t is nothing but integration of 0 to infinity e to the power minus st g eta t dt. ठीक है, इसको हम लोग एट थीटा अगर तोड़े, स्प्लिट करें तो क्या आएगा? ईटा टू इन्फिनिटी ई टू द पावर माइनस एस टी 1 dt. So this integral reduces to eta to infinity per minus st dt. Okay, now this is same as writing limit delta tends to infinity per eta delta e to the power minus st dt. Okay, now it is enough to find this integral. Now what is the value of this integral? Value is limit delta tends to infinity e to the power minus st divided by minus s eta delta. Okay, so this is nothing but as delta tends to infinity, this is nothing but e to the power minus s divided by s provided s is greater than 0. ठीक है. So what does it mean? The Laplace transformation of unit step function is e to the power minus s eta, मतलब जहाँ पे वो स्प्लिट हो रहा है फंक्शन, divided by s. So precisely if I write this one, L of g eta of t ठीक है. So this is the Laplace transformation of unit step function. ठीक है. Now if I take, you can say if I multiply the unit step function with any function, then what will happen? Now the use of unit step function is to translate a function to a certain distance in a positive direction. Means if I have a function ft, then when I multiply this unit function with f of t, then you can make a new function. You can make a new function okay. Now come to the point. I need the value of ft for t greater than 0. So in this case I am losing few points. Okay, so while translating the function, means if I draw a graph, suppose this is my f of t. Okay, starting from 0 tending towards this. So this is my t. So t started from 0. Now if this is my eta, then see, this is nothing but this function is a graph from, so I'm not getting the actual function ft, part of it. Okay, some parts are missing. So while translating a function, one thing you should remember is that you must define a function in this way, that g eta of t f of t minus eta. Then the resulting function will be 0 if t less than eta, and f of t minus eta if t is greater than eta. In that case, what happens? Initially we have a graph like this. This is my graph. Okay, now I am translating. This is my eta, translating the function. So at eta the value is at this point, so same height this point, but this is at eta. So from here so same graph, just its position is translated from 0 to eta. Okay, then the new function formed starts from this point. Okay, so this is a translation of function. Now the question is, if I translate a function, translation is important because in some situation we need to jump from one point to another, but we need to preserve the function. So in that case we usually consider this, means we are taking the function, not this function is defined from t equal to 0, but we are taking the same function from t equal to eta. Okay, so in such situation we multiply the function with the step function. This step is our chosen step, मतलब हम लोग को पहले से पता है हमको कहाँ पे जंप करना है. तो from that we will consider such step function and we will take that function or given function and define in this way, so that the resulting function bearing all the properties of the actual function starts from t equal to eta or after t equal to eta. ठीक है. Now पकड़ लीजिए हमारा ft का लैप्लास ट्रांसफॉर्मेशन हमको पता है. ओके, नाउ इन सम सिचुएशन वी नीड टू ट्रांसलेट, मतलब हमको इसको ट्रांसलेट करना पड़ेगा for some physical purpose. Okay, for some physical purpose I have to translate that function from t equal to 0 to suppose t equal to 100. Now when I translate, we know the Laplace transformation of actual function. Now when we translate, the structure of the function may change. Okay, the structure of the actual function may change, because if it is t equal to, if ft equal to suppose t square, and if I take eta equal to 1, then after translation the resulting function t is replaced by t minus 1, so this will be t minus 1 squared, so this will be t square minus 2t plus 1. So the structure changes. Okay, in this way if I consider more complex structure, then also you can see that structure changes. It has only one term, it has three terms. Okay, so the structure changes. Properties are same. Properties of this one and properties of this one would not change, because this is also differentiable, this is also differentiable, this is continuous function, continuous at all points, this is continuous at all point. It has a parabolic structure, it also has a parabolic structure. So this is same, but after translation the equation may change. So whether the Laplace transformation, and in that case, is possible, and if it is possible, whether we can find the Laplace transformation of the resulting function using our actual function. Okay, this question is answered by second shift theorem, because second shift theorem deals with this type of function. When we know the Laplace transformation of ft, then using that, how to obtain the Laplace transformation of the translated function when the actual function is multiplied by a step function, then what will be its Laplace transformations. Now this is all about second shift theorem. So second shift theorem, what is that? If L of ft equal to f of s, and g eta t ft is 0 less than t less than eta, and f of t minus eta t is greater than eta, then Laplace transformation of g eta of t, this is not of t, this is t minus eta, minus eta, t minus eta is e to the power minus eta s fs. So if L of ft is equal to fs and g eta t f of t minus eta is this is a translated function, then the Laplace transformation of the translated function is nothing but e to the power of minus eta s, means e to the power minus of the jump that we have taken into f of s. Okay, how to prove the result? This is actually easy. This is g eta t f of t minus eta is same as, because this is a step function, so you can directly write to infinity minus st ft minus eta dt. So putting t minus eta equal to z, so dt equal to dz, then at t equal to eta, z equal to 0, t tends to infinity, z tends to infinity, so resulting integration reduces to 0 to infinity e to the power of, what will be this one, minus of s, this is z plus eta, this is fz dz, this is nothing but e to the power of minus s eta integration of 0 to infinity e to the power of minus sz fz dz. Okay, so this is reduces to this one after substitution, means I can write it here like this, e to the power minus of s eta integration of 0 to infinity e to the power minus st ft dt. Why I can write like this? I can write like this because in definite integral, this dummy argument we can replace this dummy, it is zzz, we can write it as ttt by using the substitution z equal to t, so we can easily write t in place of z. Okay, now what is this? This is nothing but f of s, so this is t f of s. So proof is very easy. Laplace transformation of this translated function is e to the power minus s eta f of s. So examples I'll prove in my other videos, because otherwise video will be too long. Okay, so see you in the next video. Okay.